today Shane Hamilton. He's going to go over his really cool sounding startup called Speak AI. I'll let him get into the details of it. Before we kick off, I just want to say that we've just launched our website for the upcoming hackathon for the 13th of November. So if you go to our website, datatalk.co, you can check out our new sign-up sheet, and we've information on mentors and things like that. So yeah, I'll just let Shane kick off.
Hey everyone. This is a modified slide deck, so it's not exactly a pitch deck. I kind of tried to tailor towards more interesting stuff. So I'm just going to go through the beginnings, like the definition of the problem that's going to be solved, the current solutions, and then I'll talk briefly about is the problem worth solving, and then straight into the demos. The demos are up front because this product kind of like makes some bold claims, so you're going to have to see it, and then into results and data, which you guys should enjoy, and then some fun and some potential applications, and then finish off. I'll just go through like a tangible kind of actual deployed example of the solution. Yeah, so BeatSpeak, it started I think 2017. It was like the first code I wrote. So before that, I had been working on wearable heart rate monitors, trying to like use them to kind of diagnose and analyze stuff. And that ended up being a product for horses, and it was through frustrations in that startup that I kind of wanted to find a way of doing stuff remotely. So it kind of started off as like, I was trying to investigate using sound, using light, using all this kind of like remote sensing stuff, and then eventually I stumbled across a heap of research from MIT and a few other schools, and I was able to kind of patch together a kind of solution and demo quickly, and then that turned into this. So without further ado, the introduction. So yeah, the definition of the problem. Heart rate is one of the best snapshots you have of someone's health. So like, if someone has a heart rate of 180, there's probably something going on there. And if they're down 10, maybe something else is going on. And then more specifically, the actual beat to beat distance gives a lot of information, even about emotional state, like stuff you wouldn't even consider. But despite that, it's still relatively difficult to get an accurate measurement of your heart rate. You can wear something like a Fitbit, and anyone that's worn one knows the accuracy isn't amazing, but it's still pretty good. Or maybe like something more kind of traditional, like an ECG machine or something. But it's not particularly easy to get a heart rate, and it's especially difficult if you are a healthcare professional trying to get a third party. Obviously, you can measure stuff there and then, but getting one 24/7, which is where the real information is. So basically, if someone could find a way to do this, it would open up a lot of opportunities for like, predictive and preventative analysis. Because in medicine, generally, the earlier catch stuff, the better before damage is done. So the current solutions in most hospitals around the world, and even in modern countries, it's pen and paper. Nurses will take a pulse using their hands and write it down. You can imagine how error prone this might be, like overworked nurses working the night shift, trying to keep track of something, and someone's having a negative reaction to a course of antibiotics, and they might just miss it because there's someone in the corner that's even worse off again. The other way is you might know someone that had to wear a halter device for a weekend. And these are like quite large devices, really large. They're like the original iPods, just huge. And then there's also other vision-based systems. These are actually quite funny because a lot of them are suffer from like racist tendencies in that they work really well on someone with pale skin, but if you're dark skinned, they don't work at all. So the one I'll show you later on I developed overcomes this, and it's far more accurate. These also suffer from inaccuracies, which is, you can imagine is just a deal breaker. So that's kind of was the current state when I started, and more or less that's what's out there currently, except for what I have, or we have. So value proposition, is this worth solving? So the vision was some kind of software that would run a video, any video, and would give a doctor or a medical professional an accurate heart rate. The thing, accuracy is huge. It has to be like, incredibly accurate, but also it has to give the beat-to-beat variability, the actual signal. Just the raw average heart rate isn't enough. It has to be like the raw signal. So this was huge. So I'm going to show you the demo in a second, but just the way I came across this was I had a few ideas, and then I was going through the papers, and there's papers that were kind of getting there but weren't, and there's other papers that didn't get there but missed key steps. So that was kind of my foray into it, and I was able to quickly put together a prototype. It was actually just a Python set up in the beginning, and from that I was able to get a really, really accurate heart rate. It was really exciting. It was just one night in Stuttgart in Germany, and I got it working, and then from there it's been kind of like developed into kind of a more stable system. So this is just a few demos. I think there's some background noise there. So this is one of the very early demos. You can kind of see it's picking up the heart rate, and then this is more kind of like using the heart rate then to kind of assess risk to someone. And then let's see, what's this one? This is kind of what's happening behind the scenes. This is a clip from The Great Dictator. So you can kind of see it's measuring points, and it's also doing facial recognition and stuff, which is important. And then from there, you can kind of get, you can see the heart rate being measured. So that's kind of the way the system works. This is kind of like, this UI is designed to show people how it works, but when it's actually being used, you're not actually looking at any video. It's working behind the scenes. It's just giving you raw data points. So this is the data. So this is from some papers of the research I use, and then also research we carried out in our own stuff. So the big thing to take from this is the percentage error. As you can see, it's quite low when it's measured against the gold standard, which is the ECG machine. So these are really exciting results, and this is what when we did these tests, it was with an earlier version, so it's even better again now. Yeah, so measure the heart rate. You kind of think like, so what? Like, so can a Fitbit, and who cares? Well, the reason is because the accuracy and the reliability of this, it opens up some really cool applications. So these haven't been developed yet, but I'm going to go through them because papers have been published on them, and it kind of shows where the roadmap is going. So early detection is huge in medicine. So like, some statistics to back it up. So like breast cancer has a 90% survival rate when it's caught at the early stage, and it reduces to 15% at the latest. And it's the same for most cancers. And then on the right of this, I just kind of, just a brief kind of like overview of the body's blanking the word now, response to stuff. So you can kind of see this is how like a lot of stuff will show up in the heart rate. So these aren't papers research we've carried out, but they've been carried out by third-party universities. So you see when you feed in this heart rate into this deep neural net will predict diabetes with a 95% accuracy. And this is something similar. You feed into heart rate, and the deep neural net is 99% accuracy to the AFib. And this is just some more data around kind of like stuff like, heart rate, seizure. The one on the right actually is literally just using a camera to detect breast cancer, which is actually it's really interesting. And each of these is like a standalone study done by a separate university. And then this is just, this is actually pre-COVID, the slide was made, which is funny enough, but it's just showing like the cost of flu and stuff. And then the bottom, it's just from a random form showing some guy who was able to predict his becoming sick using his Fitbit. So yeah, just go into a more tangible example of something that's actually been used as a business. So on average, these numbers are based on Ireland. So the 8 patients over a 12-hour shift, they measured on average, they measure the patient's vitals every 4 hours in Ursula, and it's put into a chart, and then it's used basically to analyze the risks of the patient's life. So each nurse in Ireland will do this. So there's 10,000 acute beds in Ireland. So that kind of corresponds to 1.5 million hours a year for Irish nurses doing this. That number is 40 times larger in the UK, 93 times larger in the US. So this is basically a task that's been done every day. And with the system, this can be automated, freeing up time. And as we know, time is money. So yeah, so this is the current solution that's used. It's the pen and paper. You can kind of imagine the difficulty in reading this and filling it out and stuff, and how stuff might be dropped and lost and stuff. Yeah, so you put the figures in, and then you can kind of see that the HSE is spending 30 million a year on tasks that can be automated. That's going to show you the kind of impact that's potentially possible. So this is an example solution that we tested out. So it's you don't really know that's cloud based, or that, but it was basically running hardware in a hospital. This is what it looked like. You can see the kind of two cameras, and then the other device is what the medical professionals were using to monitor heart rates, action. And this is kind of like, this is a halted device. This is what was used before. So you can see that going from a remote device monitoring just passively, and this is the current solution. So it's a kind of a big improvement in comfort. So here is just some of the challenges in doing a medical device, especially in Europe. So what we have is a class 2A medical device under European standards. So as you can imagine, you have to do a lot of medical certification and testing before you can start making claims about your device. So that's quite expensive. That's why we had to raise capital to do it. Clinical trials. So then, yeah, let's keep going through this. I can come back to this later on if people have questions specifically, but this is actually the process it requires to get a device certified in Europe anyway. And it takes about 2 years, and it's just every step there is just a massive expense, as you can imagine. And you have to do this each time you change the software too. So it's good because you kind of want to make sure that your medical devices are working properly. But as a startup and innovating, it can be quite difficult. So our strategy is basically partner with bigger companies, the existing medical companies, get them use their expertise to kind of like cut down the costs and stuff, and get them certified. And that's worked out really well for us. And then impact. So while we're doing this, we also open source the core technology, not the solution, the technology itself, the engine. And then, so this opens it up for people to kind of develop their own products. And this is kind of geared towards being used in developing countries for remote medicine, to kind of give doctors that extra bit of a diagnosis tool. Yeah, so I kept it short and sweet. I'm probably a bit too short, but I'll open up the questions now. See, we'll stop sharing her.
You can keep sharing there. I had a question, Shane. So like, what are the visual features in a face when you're recording a video that actually help you predict?
Well, that's a really good question. I'll probably put into the slides. Right, so there's two ways. The existing way is your blood color. So as your blood oxidates, the redness changes. So if you measure the pixels on someone's face and hands, or her face and hands, and you measure the R value, so RGB, and if you measure that as a signal, you will get the heart rate that way. That's the existing way. And the way I did it is based on some papers published in the US. Every time your heart beats, your head moves slightly. It's because your head's on a swivel, and it's the Newtonian mechanics of the liquid movement to your head, so your head will move. So if you simply track the motion of the head, you can get a really accurate signal. That with digital signal processing. So what you're doing is you're taking the coloration of the skin and then the movements in the body, which are moving to rhythm of the heart, and that's kind of being processed down into heart rate. Is that answer the question, or should I go into more depth?
No, I think there was enough depth. That was good, thanks. Is there any more questions, guys? Oh, there's one in the chat.
I can't see the chat. Let's see.
Someone asked, could this be applied to mobile phone cameras?
Yeah, that's a really good question. That's exactly what I'm working on at the moment. Because you can imagine in the developing world, there's 2.5 billion users of Android. So at the moment, I'm developing a library that anybody can develop an app around, and so that's kind of the next step. Is the big impact is free to use on an Android phone. So the answer is no, but soon. That's a really good question.
Is the prediction made on the hardware connected to the camera, or can it be done remotely?
It can be done anywhere. So it runs in video. So if you've seen in some of the demos, I was using old Charlie Chaplin movies. Like it's just any video at all, the software will run on. And then beyond that, it's like developing custom solutions that the customers require. So in hospitals, for example, there's a lot of requirement to use stuff on site. So you have to have your server on site in the hospital in a safe because of data protection stuff. But I mean, like it could run anywhere on webcams and whatnot.
If you've any other questions, guys, pop them in the chat. I suppose I'll ask another one. Is there any other applications you reckon outside of the medical industry? Like, do you know when you go into the gym now? Well, not right now, but last week, they have those like temperature checkers and stuff. Like, do you think you'd be able to deploy it in a shop without the medical certification?
Yeah, I mean, like if people want to use it for gauging an audience reaction to a movie, gauging reaction to advertisements, just people trying to use it for want to use it for lie detectors, and and then there's also kind of the epidemiology side of it. So like airports and places like this, it can be used to kind of like pick up on like infection. I'm actually trying to downplay this bit because the whole COVID stuff, but so each one of those applications discredits the main one because it's been used by doctors and medical professionals to actually like put it out there. You're actually, you're watering down the brand as such. So if you're using it like for this other stuff, so we've kind of focused down on kind of medical certification and a high quality product. But yeah, I mean, epidemiology for like tracking infection through the population, or even airports tracking like suspicious behavior. If someone's highly stressed, they might indicate that corrupt's not good and stuff. Trying to think of other applications. I think potentially could be used in animals, which was an interesting one. But there's more applications. There is time to work on them all, so we're going to have to focus. How hard is it to introduce a product tech in medical compared to other sectors? Incredibly hard. I don't know anything that's harder. Maybe the space industry. And for the right reasons. In the US, you have something called, I'm not forget this now. There's like a special certification in the US where you can like say that your device is similar to an existing device. So, and that can like fast track it in like in a few months rather than a few years, and it's much cheaper. But you have situations in the US where like you had to say a hip replacement, and then someone else certified it against it saying it was similar and it was okay. And by the time the 10th person had done that, it was like I think it was like they used ceramics or something. So like we probably could have went to the US and got it done much quicker, but the European Union was so much harder to do it in that we thought it would kind of give more credibility to what we're doing. But yeah, I mean, I can't imagine doing what we're doing now without raising capital and partnerships and stuff. Whereas in other industries, you can like bootstrap and you can like, you get your customers and you can kind of do it easy. Whereas in this, you kind of have to get so much done before you can even make a sale. So it's really difficult, yeah. But at the same time, like it's a massive impact, so you kind of it's worth doing. Is there anything else like this on the market being developed? There is, there's 2 or 3 solutions based off of just the skin color. So our unique innovation, our leap of insight, is taking the movement and top of the coloration of the skin, and then we also have like a lot of really kind of custom signal processing stuff that gives us much more accuracy. But there are ones that use the coloration of the skin. That one is about, I'd say, 5-10 years old, and just products like baby monitors, and I think there was an app in the US where they were using it as rescue services. But the problem with those products is obviously the accuracy. So yeah, like, there's always competition, which is good. Like it means that like when we were starting off, it kind of gave us we knew that we were onto something because it was possible to do. Do you need to be actually pitching it to different clients, or have clients come to you looking for it? Yeah, so this is my second startup, and I've literally been trying to kind of keep it low key, because we can't keep up with demand. Like it's difficult, and also because it's a long process to get it certified. So we're trying to like not kind of build up too much hype and then disappear for 2 years. So this one is different, right? This one people actually come and are interested in it. So I would say the answer to that is no. But then again, I could also say that maybe if someone's criticized us, they'd say we could be doing more on the kind of promotion side of stuff. But I mean, yeah, that's a good question. We're not actually pitching them. We don't even have a website. We took it down recently because we're trying just to keep quiet. this talk obviously doesn't make much sense. But no, we don't have to be actively pitching. No.
It's brilliant. We might wrap up there unless there's any more last minute questions. But yeah, that was fantastic, Shane. Thanks so much for coming on. Like I said earlier in the talk, guys, if you're interested in what Shane has to say, give him a follow on social media or something as well, and make sure you check out our website for more events. But yeah, thanks a million, Shane.
Yeah, so you guys keep an eye out after Christmas. We'll be launching big launch. Hopefully it'll be the developing world product, but it'll probably be something a bit more boring. So yeah, keep an eye on the space. Thank you.
Brilliant. Thanks, Shane.